Good afternoon, and thank you for tuning in to part 2 of the A5HF1 series. My name is Bill Brayton. I am Senior Research Technician here at ATRA. And before we get going, we need to take care of some business here and thank our sponsors. We want to welcome you to this wrap-up series, Steel Aftermarket Products, your source for engineered solutions. And once again, we have a video for you guys.
Steel Aftermarket Products engineers and manufactures Toledo Transkit with the rebuilder in mind, including everything you need to get the job done right. Toledo Transkit is the #1 choice of installers because of all the intensive research and development that goes into each component in every kit, like re-engineered valve body gaskets, preventing EPC damage by eliminating the shredding you get from original equipment, plus all of the extra essentials that are included, like spring and screen filters that should be changed at overhaul. Toledo Transkit even includes loose valve body gaskets that fit all 19 bonded separator plates. At Steel Aftermarket Products, we don't just make kits, we make kits better. Ask for Toledo Transkit by name.
Alrighty then. Here we are, getting towards the tail end of our webinar series for 2016. This is the third last to go here. Next we have drivability diagnostics and hybrid diagnostics, and I would personally like to thank each and every one of you guys for allowing us to into your shops and into your computers there for a period of training during your day, when we hope it's convenient for you to enjoy a sandwich, a little break time, so that we can spread the knowledge that we'll hope will improve your shop service and helping you get those vehicles out the door. So thank you again for attending. And also throughout the year we've said it's time to pencil it in. Well, it's time. Do you have your reservations for Las Vegas? October 27th through the 30th at Paris Hotel in Las Vegas. I know I'm certainly looking forward to heading over to a new venue, a bigger show floor, lots of exhibitors, lots of tech. I'm personally looking forward to presenting a Transmissions 101, a very simple course for entry-level attendees. They can learn about the very basics of automatic transmissions, and all the way up to the latest tech presented to you throughout the expo period. And so hopefully you have your reservations for the 27th through the 30th, and I look forward to seeing you guys there. Of course, any questions or comments you have, please feel free to send emails to the webinars at ATRA.com, or if you have any questions you might have while this webinar is going on, please feel free to type it into the text box there, and we'll get those questions answered straight away. If we don't have the answer, if I don't have the answer to the question, I will research it and get back to you personally. And of course, this is just a review of the email that was sent to you so you could get a link for the handout. You should all have the handouts by now. And so let's get going. Just as let's get going here. As a slight review, the Hyundai Kia come with the A5HF1 3.3, 3.8, and 3.5 liter models. Mitsubishi uses the same type of transmission, and it's called the F5A51. I'll point out some differences during the next half hour or so. One of the main differences being is the F5A51 series is a 6-solenoid setup, 6-solenoid valve body, where the Hyundai Kia A5HF1 uses a 7-solenoid valve body. And this pump setup here is a pretty straightforward gear rotor type pump with a crescent. The dots on the left you can see always face up. And when I was speaking with the hard parts guys on what was selling and what was not on this unit, they had a high number of incidences that this pump was being sold over the counter and over the counter. So the reason for that is it not that the A5HF1 pumps are failing rapidly or with a very high incidence. It's because this type of pump works in the F4A series, F5A series, the A5HF1 series, and the A5GF1 series as well. So just know that that's why there's a lot of these pumps being replaced, because they go over a very wide range of applications. So the pump's pretty straightforward. The problem is pump alignment. And here, let's take a look at a couple of different methods of pump alignment. Here's the pump alignment without an alignment tool. Okay, it can be done. The pump to converter housing and the stator support to main case housing is very tight, almost a press fit, an interference fit. So we can use the case and the bell housing as alignment fixtures. Simply, we're going to put the pump house together finger tight, and we're going to bolt the pump to the main case. So of course the main case is doweled for the alignment of the bell housing. So we can put the bell housing down on top of, put the bell housing here and then the main case together, put a few bolts in it, tighten it up. Now we can flip the case over and go down through the case halves. We'll see the bearing support out of the case here. We don't see it here, but a clear path to those bolts where we can snug those bolts up fairly tight. And now we can split the case halves and torque the stator to pump body bolts to 90 to 110 inch-pounds. You might want to make a note here. The handout that you have, I made a correction because I noticed this was messed up to begin with, was your handout might say 909 to 110. That is incorrect. It should be 90 to 110 inch-pounds. Certainly not 909 inch-pounds. So 90 to 110 inch-pounds after we've done it. And that is a safe, practical way to put the pump halves together. And we know for a fact that once we get it back together, it'll be lined up and you won't have any gear noise or pump gear breakage. Or the alternative method is to use an alignment tool. We can tell you about Sonic's alignment tool because it's the only one that I know of that's on the market. And we simply just put the pump bolt halves together, finger tight, slide the pump alignment tool down into the pump. And this particular tool indexes on the new pump bushing that we've put in the body, and up inside this tool, it's machined with the journal that fits exactly down into the stator support right here. So this is indexed through here and the bushing, and now we've got a perfectly aligned pump. Flip it over and tighten the bolts to 90 to 110 inch-pounds, and you're done. You can see that this is a much quicker, effective way to do it than the alignment without it. Either way is acceptable. That'll keep you from having pump gear noise, whines, or gear breakage. However, That being said, do not use this method to align pumps. If you've been using this method anywhere in the past on this pump or any other pump and gotten away with it, I need you to go buy me some lottery tickets because you've been extremely lucky. There is nothing to hold the pump half and the stator support in line down inside that converter. So how do we know that? Well, we cut a converter apart to show you. Here we could see the stator on the far left. That's supported by the splines on the stator support. Nothing there to hold it in line with the impeller. And right in the middle, we can see the impeller has a sealing ring here and a seal here right in the center. That seal seals the input shaft. It has nothing to do with alignment. And now on the far left, we see the converter clutch piston right here, and you can see the converter clutch lining on the outer part of the piston. Of course, that seat's down here in the shell. But if you look down in the center, there's nothing holding this in alignment. The only thing that holds this in alignment with the stator is the crankshaft pilot. Once this is bolted up, now the stator support and the pump bushing support the rest of the converter. So what my point here is, there's nothing aligning any of the converter clutch to the impeller, to the stator, to the pump hub to hold any of that in alignment. So if you've been using the unacceptable method, which I'll be honest with you, I might have done once or twice in my career somewhere along the line, I have to tell you, before I learned that it was completely unacceptable. I was one of those lucky guys. That you need either the special tool or the alternate alignment method to put these things together, so you know that when you put the unit into the car that it's not going to have a gear noise or going to have any pump breakage. So it's very, very critical that we use the correct tools and proper alignment procedures. Okay, moving right along. Here's a breakdown of the Planetary Gear Set. The number 4 thrust bearing has no race between the sun gear and the bearing. If you pull this apart and this bearing is pitted, we have some rough surfaces here. It's probably going to take out the sun gear with it. So if you've got a bearing that needs to replace, chances are you're going to take out the underdrive sun gear as well. Here's a look at the Spragg Assembly. Blown apart for you guys. Washers on the top and bottom. The lip faces up for reassembly. And here we've got the inner race in. This will actually spline to the support down in the case. We'll show you that here in a little bit. When we have it properly assembled, it'll freewheel counterclockwise and locks clockwise. Okay, the only reason I point this out is because I missed it myself. And just be aware that there is a snap ring there where we can pull the input shaft up out of the drum and service the clutch drum without any kind of fancy tooling. That may seem simple, but I had this thing set up on with a special sleeve and all that, and then I pulled it apart. Oh, look, there's a snap ring. Okay, so just to point that out and save you guys time. Here's the blow apart of the drum. Pretty straightforward clutch drum. Only highlights here are making sure that the spring, return spring retainer is dialed with the nubs on the piston. There's holes in the retainer that should line up correctly. Otherwise, you're going to bend up the retainer pretty bad. Also, I want you to note, and this will be a theme through this whole unit, right here in the center picture, the steel plates have wider slots in them between the two here and the two here. And that is to channel the oil out the drain holes. The information I saw calls them lube holes. I believe they're there just to move the oil away from the clutch friction plates. When they come together and push the oil out, that will centrifugally get rid of any oil that's in the way of the apply. Here's the direct drum clutch assembly. This has the retainer that needs to be indexed into the piston as well on the left. And in the center, in the circle there, I'm showing you the backside of the plate. The backside of the plate has a step. And I want you to pay close attention to the stack up here. It has a backing plate and then a wave plate. Then it goes friction steel, friction steel. Notice there's 3 frictions there. And what I would request that you do when you pull this unit apart, when you pull this drum apart, have some tag wire right there to tag the stack up and set it aside. This is very model dependent, and it may vary from Kia to Hyundai to engine size. So for your benefit and the builder's benefit, have them wrap this up with tie wire for proper assembly when it goes back together, and nobody will stand around scratching their heads wondering which step plate went where. That becomes very critical just from an assembly point of view. Okay, here we have the wide slots again for our friction plates. As far as our stack up goes, once it's all stacked up, you'll notice that it's 23 to 31 thousandths clutch clearance when you're measuring for to see if we've got the stack up correctly. Lastly, here's our overdrive reverse drum assembly. Once again, it's pretty straightforward. It's got the notches for the return springs as well. And the overdrive clutches, you will notice, are single-sided frictions. This is another clutch pack that I request you wire tie together before you blow everything apart, so that you know the correct stack up. This stack up will vary as well from model to model, engine size to engine size. You'll notice that this is a one-sided friction clutch pack, except the top one. The top one's a double-sided friction. So you want to pay close attention to that, and I would just like you guys to wire that up and set it aside for ease of installation. And of course, there's just a couple of reverse clutches on top. Back to the theme of the wide gaps go with the drain holes in the drums right there on the left. And on the right, we show our clutch clearance inspection. Please note on the reverse clutch, we have, those are waved friction plates, okay? So we want to get a correct reading. We're going to push the frictions down to collapse the waves to get a good reading. And our clearance here is 59 to 66 thousandths. Here's our direct planetary gear set. This was the biggest socket I have in my box. It was a 50mm socket, so we can pull this thing apart. Pretty straightforward. The nut comes off, bearing and the races come off. We can set it up in the press to press this thing apart. And here's what it ends up looking like once it's all blown apart. On the right there, you'll see the thrust bearing and race. It only has a single race and the Torrington bearing. The bottom of the roller bearing that fits in the bell housing case to support the shaft is actually the other race for this Torrington bearing. So if the bearing's chewed up, obviously the race and the bearing, the roller bearing, are going to have to go. On the far left, the direct planetary gear set here, that is the 4-pinion. This is one of the places that are built up here over the A5HF1, which only has 3. The A5HF1 has 4, and that's one of the other major differences in the unit. Going back together, we need to use a suitable driver. This particular setup for this webinar came from easydriver.com. That should be in your handout. If you're looking for a driver set, talk to Mike over there. This is a really, really well-built set. Comes in a really nice carrying case. If you're in the market for that sort of thing, really, I would take the time to check this out. And so we get the tapered gear pressed back onto the shaft. We can flip the pinion gear over and put the park gear on the pinion gear, put the shaft down in there, and press that assembly together. Now here is the 50mm socket lined up and get ready to torque the nut on. We can run this down with, okay, you can run it down with your impact wrench, but that's not the final torque. That's just to seat it on the bearing. Okay, I want you guys to make sure that you heard me correctly. It is unacceptable to make the final torque with an impact wrench. It's acceptable to seat it down onto the bearing, but to torque the nut to the 125 foot-pounds, we're going to wait till the final assembly. This picture is not, I added this picture this morning. I just wanted you guys to get a sense of when we're going to torque that nut to 125 foot-pounds, because it's easier for the park pawl to engage when the unit is in this stage of assembly than it is to hold on to the shaft as we see it right here and get it to 125 foot-pounds. I couldn't recommend putting it in a vise with a couple of 2x4s and trying to get that to come together when I can put it in the case like this and have a helper, or even by myself, torque this to 125 foot-pounds and then stake the nut correctly. So that's the correct way to get that thing torqued down, right there on the final assembly before the bell housing comes on. Okay, here's the valve body and the ohms valve body solenoid identification and ohms resistance. All these solenoids are identical. That is, the clutch and torque converter clutch solenoids are identical. The line pressure control solenoid in the lower left is the different solenoid. And I don't have a hydraulic diagram in this presentation, but it would show you that this solenoid is not a pressure control solenoid like a General Motors or a Ford product solenoid that raises minimum to maximum line pressure. This is more like a late model 41 TE that has a variable force solenoid on it, in that they are both pressure reduction solenoids. They reduce the pressure when in times of no load, at cruise, at a stop sign. Anytime the computer sees the load value go below a certain percentage, it clicks on this solenoid and knocks down line pressure. Now, why would it do that? Well, it would do that to reduce the load, which would increases fuel mileage. If we decrease the load on the engine burns less fuel, and less fuel it burns, the more mileage we get, and more mileage we get, federal government really likes us. So to take the load off of the engine, they are using a pressure reduction solenoid. It's called a pressure control solenoid in any kind of publications you might look at, but technically it's a pressure reduction solenoid. Okay, so here's what it looks like with the solenoid body off. The center plate that you see there is with the solenoid body off of the main valve body. That will kick up because there's some check balls underneath there. On the far left is the separator plate and end plate for the solenoid body, and you can see they added, instead of adding a hydraulic passage to the valve body, they added a hydraulic passage into the top plate, channeled it through from one end to the other to feed the line pressure solenoid. Here are the small parts for the main control valve body, and now we can see the two spring balls underneath the separator plate between the solenoid body and the main control valve body. Here we have a breakdown of the valve body, and the thing I want you to notice here on the upper left is the 0.348 gap from the factory. This is a stone factory valve body that I measured out of a very, very low mileage unit. So if you have any questions or you need to take that apart, that's what it looks like when it goes back together. Same goes for the solenoid reduction valve. Over on the lower right-hand corner, that is the measurement that came across my bench from this factory unit. The solenoid reducing valve, they call it a solenoid reducing valve. Many other units call it a solenoid regulator valve. Ford calls it a solenoid regulator valve. GM calls it an actuator feed limit valve. They all do the same thing in that they regulate line pressure down to a pressure that the solenoids can handle. Here's the solenoid body valves out and apart. Notice that they are all pressure control valves. Well, all but two of them are pressure control valves. And if this looks familiar, once again, it is. This is like the distance relative to the 604 valve body, in that they work exactly the same. The solenoids are fed oil from the solenoid reg valve, and they use that pressure to regulate these pressure control valves. The main line pressure that is eventually going to the applying component is fed through each one of these regulator valves, these pressure control valves. So the solenoid controls the regulator, or I keep calling them regulator valves, pressure control valves, and these will then send the oil off to the apply component, much like a 604 has been doing since 1989. Here's the transfer gear out of the case. We can see the dots there. That's where the slots in the race lines up. I recommend that we do not put this in the cleaning machine. The hot fluid, the hot solution comes out, gets dry, gets caught up in those bearings. I don't think that that's good for those bearings, and I also don't think that this needs to be taken apart every time. I believe that it can be removed from the case for cleaning, light cleaning with solvent and maybe some brake clean and be set aside, lubricated fresh ATF, and I think we're good to go. Another assembly tip, you want to be sure that you've got the piston lined up correctly going down into the case when we're installing the L&R piston. I, quite frankly, missed this one. Put the unit back together, and the clutch stack up was really out of whack, and I had to take this thing back apart and figure out what the heck. Oh, look at that, missed that nub there. Make sure that we get this the nub on the piston down into the recess in the case, or else we can avoid, or we'll get some low reverse clutch damage, or the piston, or both. Now, here's the flip side of the race I was telling you about earlier. It's got a lip seal on it that will seal lube into the Spragg, so it's very important that this be renewed when we are going through the unit. You could see the slots in the race here that line up with the dots on the gear support. Yeah, you want to be sure that that lip seal gets replaced each and every time. We have the band and the anchor bolt. It's very difficult to put this new band down in the drum first and then work the drum down into the band, because there's nothing supporting the band except the drum. So it's a little tricky. It's easier to pull the anchor bolt out first, drop the drum down in onto the support, put the band in, and install a new O-ring on the anchor bolt and screw that anchor bolt onto that into its proper location. It's just too cumbersome to. That's a triple wrap band, and it's very difficult to get the band, the drum through the band. Lastly, we've got the front end play adjustment. Man, this couldn't even be easier. This tool's been around for many, many years, and it's still as effective today as it has been all those years back for checking end clearance on the front here. It's adjustable by a selective washer that fits down into the drum. Okay, and lastly, like I said, one of the main reasons I put this show together, the parts 1 and 2, was the simple lack of good, reliable information. And Mitchell AllData does not have this sort of thing. So that's why we put this information together in a place for you that's going to be easy to find once we get both of these handouts up on our website. And I've included torque specs for you guys. And if I'd like any questions or comments you guys might have as we take it out. And thank you again to our sponsor, Seal Aftermarket Products, your source for engineered solutions. And I'd like to thank you all for attending throughout the year. It's been a personal pleasure to come into your shops via the internet and share some knowledge with you guys, and look forward to seeing you in Las Vegas. Look forward to seeing you here online next year. And if there are no questions or comments, I'd like to say my name is Bill Brayton, and have a wonderful rest of the day. Thank you, and good day.